Hello, welcome back. Today we'll be learning how to use digital inputs. In my last video, I showed you how to use pins 0 through 13 as digital outputs. Today I'll show you how you can use those very same pins as inputs. As these are digital pins, our input value reading will have one of two states. High, if the Arduino senses a voltage of 5 volts, or low, if the Arduino senses the pin is pulled to ground. Digital pins are useful for connecting and implementing switches and other switch-like devices in your projects. So let's get started and build a circuit that makes use of digital inputs and buttons. In this case, we're going to reuse the old circuit we built for our LED, which is also redundant as we're using pin 13. So when pin 13 is turned on, not only does this LED turn on, but the built-in one does too. At the same time, we're also going to be adding a button. Now basically the way a button works with a digital input is the input pin is going to sense whether there's a high voltage coming in or a low ground voltage coming in. So how do we do this? Once again, we're using pin 13 connected up through a resistor into our LED with, of course, the LED's cathode pin or going to ground and the anode going to the resistor, which then goes to pin 13. But now, more interestingly, let's look at the button circuit. The button circuit here is comprised really of a button which is put across two separate kind of rails. And down on one rail, we're going to attach our pin 4, which is going to be our digital input, to one end of the button. And at the same time, we're going to attach a 10 kilo ohm resistor to ground. So that this button, when it's not pushed, we want it this side to be in ground. And as a result, this pin will read low. If the button is pushed, we have here on the other side a connection to 5 volts. So if the button is pushed, 5 volts will flow across here to the other side of the button, will be measured as a high voltage going to pin 4. The pin 4 will read high. Then the logic in our program will turn on the LED. And when we let go, the pin will be pulled to ground. Now we're not creating a short circuit or frying the Arduino because our connection to ground is going through a 10 kilo ohm resistor, so 10,000 ohms. If we didn't have this resistor and we just made a direct connection to ground, this pin would never be high because it would always be shorted to ground and it could burn out our Arduino. So always use a very high value resistor here. Now let's do a little bit of a close-up so you can get a better look at this. So now we've uploaded the code to the Arduino. When we press the button, the LED turns on. As you notice, both the built-in LED, which is kind of hard to see, it's covered there, and the external one light up as they're both on pin 13. So when we push the button, 5 volts flows from our 5 volt rail over here, flows across the terminals on the button, and then we read a high signal in our pin 4 via the yellow wire here. And when we let go, this 10 kilo ohm resistor pulls the button back down to ground. If we didn't have this 10 kilo ohm resistor, the button would float between 5 volts and ground, and the LED would turn on and off intermittently. Now we can test this very easily. If we disconnect this and we take out the resistor, this pin now is floating. It's neither at 5 volts nor at ground. And this causes a problem. You see, the LED lights up because the pin is confused and doesn't know if it's really grounded or if it's floating in the air. It's the same as if we disconnect this from the circuit entirely. We don't really know. You notice when I touched it, it turned off. My body grounded this circuit, resulting in the pin being read low and turning off the LED. That's why you always need a resistor, a high value resistor, going to ground. So let's start by declaring some variables. First of all, we need to declare our LED. That's going to stay the same as pin 13. And we're also going to declare our button, and for that we can use any digital pin. In this case, you can take a look. They're labeled from 0 to 13. I'm going to choose, let's use pin 4 for our button. We're going to use more variables later on, but for a basic circuit, this should do. Then in our setup, we're going to want to set the pins as output in the case of the LED pin, and in the case of the button, we're going to set it as an input. And that's really all you need right here. Then inside our loop, we're now going to do something called a digital read. What we're going to do is we're going to also create an if statement that's going to test a condition. In this case, we're going to say if digital read and button, and then we want to say equal to, and now when you declare a variable and you say set this variable to a value, use one equal sign. When you want to compare whether something's equal to another thing, case of two variables, you use two equal signs, and that's the comparison operator. So we're going to say if the digital pin 4, which is our button, is high, we want to set our LED pin to turn on. Now, if that's not the case, all we want to do is turn off our LED pins. So we're going to do a digital right LED pin, and we're going to set that to low. Now spaces don't really matter, it's kind of your preference. Next we're going to basically verify this code. Let's save it as button, let's say, yeah. And you notice we now have an error. What did we do wrong? Well, let's take a look in this case at our curly brackets. It tells us here expected declaration before closing curly brackets. Look at the main loop function. It opens and closes. The if statement opens and closes. The else opens and closes. So that means there's one curly bracket too much. Delete that. Verify the code again. Code is good to go. So now what we can do is hit upload and upload it to our Arduino. So we've just used the push button to turn an LED on and off, although to be honest that's not all that impressive, as you could do this without a microcontroller. Simply wire up a button or momentary switch to an LED circuit. So we are going to learn how to use a button as a toggle and how to debounce it. Now when you push down on a button, the button doesn't make immediate perfect contact. The button might hit one side of its metal plate first, then the other. This may lead to multiple on and offs, which are called bouncing, where the button bounces between two states very rapidly. We can see this happening here. You notice sometimes when we turn it on or off, the LED doesn't do what we want it to. Now we can fix that by running some special code to debounce our Arduino. Now, I've looked at many forms of debouncing and over the years written different kinds of code for this, but I find that the best solution for debouncing is actually in the Arduino's examples. All you do is you go to examples, digital debounce. Now, it should be fairly obvious, but I want to make it very clear this is not my code. This is the standard Arduino example. It was written by a lot of very qualified people. And I find out of all the things I've tried, this generally yields the best results. So I'm going to explain it to you now. We're just going to first, of course, they also start by declaring the pin, except we're using pin 5 for our button. And this is, as always, declaring the variables for the pins. Then they declare several other variables that are going to store the state of the LED, the state of the button, and the previous or last state of the button. Now, they're using integers, but in reality, they're using them as a Boolean value. You could change this all to bools, it would also work. Now, then they're creating also two variables, which are long integers, because they're going to be measuring the amount of time since the last button press. And this variable will be in milliseconds and will grow very quickly. That's why they used long integers. Then they do another setup, well, the usual setup, set the pin modes for the LED as an output, the button as an input, and then they write, do a digital write to the LED pin to turn the LED on when the program first runs, but you could erase this. Now this is where the interesting stuff actually happens. In the loop, they first create a new variable called reading, which will store kind of the latest state of our button into this variable. Now, after they do this, they're going to check if reading is different from the last button state, which initially starts out as low. If it is different, aka not equal to, it will then reset the timer. And the timer is last debounce time, and it's equal to millis. Millis is a built-in Arduino function that tracks how long the program has been running from the start. So it's going to use this each time basically the state of the button changes, it's going to reset the debouncing timer. Because this timer is then used in the next if statement, where they do millis, the time the Arduino has been on, minus the last debounce time, and basically the difference, this will lead to a positive value. They're measuring the difference between the time the Arduino has been running and the time the button has been pressed last time. Now, if this difference is bigger than the debounce delay, or basically this is kind of like a threshold, which they set to 50, if it's bigger than 50, we're going to assume, the code will assume, that we meant to press that button, that the button is actually been pressed. Now this is important because when you push down a button, it doesn't immediately result in button being pushed and a high signal. The button bounces up and down and the signal quickly fluctuates between high and low. This is because the button is a little metal sheet and it doesn't perfectly make contact on the first press, and it takes some time. What this does is basically immediately, as soon as there's any indication that the button has been pressed, if it meets these conditions, for example the threshold, debounce delay of 50, the code assumes you meant to press that, it ignores the bouncing, and then it will turn on the LED. But before it does that, again, it does another reading. It says comparison. If the reading is not equal to the button state, so basically if we just read the pin, if it's not equal to what we officially saved in the button state variable, we're going to set it to be equal that, because button state should be equal to reading. And this is basically measuring if the state of the button has changed. Now, if the button state is still high, because it's being pushed down, it's going to invert the value of LED state. So if this was high, it'll turn it to low. If the LED state was low, it will turn it to high, basically toggling it on and off. And the reason you see this not sign or the exclamation mark, it's basically to invert a Boolean value. Even though they declared these things as integers, these could all be declared as Boolean values. A Boolean value is basically a binary value, a true or false, high or low, or a 1 or 0. Basically a two-state variable. And finally, the digital write to basically turn the LED on and off based on the LED state variable. And then last thing that has to be done is they save the last button state. They save the reading to be the last button state. And this is important because if we look back up here, it's going to take a reading again. And if the reading is different from the last button state, it knows that the switch has been pressed, and it once again resets the debounce timer. And this code once again runs when all these conditions are met. Now, if we run this new code, we notice that when we press the button and let go, it turns on and off each time, just the way we want it. Doesn't matter if we hold it down, if we wiggle the button, or if we push very quickly. The LED turns on and off correctly, never missing a beat. So, today I showed you how to use digital inputs and buttons. One of the key takeaways here is how to debounce buttons. As without debouncing, buttons can be a real pain to work with. If it seems a bit confusing, check out my full written guide in the link in the description below. I'll go over the entire process step by step and explain every line of code. In the next video, I'll be covering analog outputs and pulse width modulation. We'll also be building a circuit using RGB color changing LEDs, so stay tuned.